Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 17th video in the Introductory Programming in Java full course and the 8th and final video of Lesson 3, Branching Structures in Java. In prior videos, we've covered just about everything having to do with branching programs in Java: relational and logical operators, comparing strings, Boolean variables, checking ranges, if-else statements, nested if statements, serial if statements, switch statements, the ternary or conditional operator complements of Boolean expressions, and assert statements. In this video, we're going to look at the best ways to test and debug branching programs. Let's get right into it. I'm going to be showing you some programs that appear to be working correctly if we casually run them on a few inputs, but that have errors we can discover with a thorough set of test cases. We'll talk about how to design that thorough set of test cases and how to debug a program when we find it isn't working correctly. Just a side note, the debugger is also a great way to help you understand how Java structures impact flow of control and program state if you're not completely sure. Here's our first program, Simple Quiz Switch Buggy.java. This is like the program from the last video, but to facilitate testing, I've changed the messages so it tells the user what they chose and whether it's correct or not. Let's run it with an incorrect answer and a correct answer. So I'll run it and enter A. And it says you chose A is not correct. And I'll run it and enter C. And it says you chose C, well done. This is probably about as much testing as the average learner might do. It's hard to try to break your own program, especially if you worked hard on it and it took you a long time to figure it out. But this program is not correct. How do we devise a thorough set of test cases for the program? With a branching program, you want to test each branch. Now, with a switch statement, because each branch is reached through a test for equality, we can test the program with each value for which there is a case. In this program, that is uppercase and lowercase a, b, c, and d, and then there is a default. We want to ensure that the default is reached if and only if we enter something that isn't a, b, c, or d. I want to note that we're not going to be testing for the user entering the wrong kind of data at a prompt, because we haven't learned exception handling yet, which is how you would handle that. There are videos on this channel about how to test for that in my Intermediate Java playlist. I recommend you work through the Introductory Java first, and then move on to the Intermediate. To test the program, we need to first specify the expected output. I have a table here with 3 columns: input, expected output, and actual output. And I've filled it in for this program. Notice that we need to test lowercase and uppercase a separately, and the same for the other letters. For the default case, I've put a row for E. We can't test every single invalid value because there are too many, so we should also test our assert statement in the default case to ensure that it is correct, and will therefore throw an exception if we reach the default case when we shouldn't. And that would be if the user has given a response that should have been handled by one of the other cases. Okay, so I'm going to test this by entering each of these inputs and speed the video up, and then we'll look at what we've got. Okay, so I told you this was broken. We get the expected output for uppercase and lowercase a, b, and c, and we get the expected output for E. But for D, we get both the expected response and the response for the default case. Let's run the program in the debugger and enter D so we can see why we're not getting the expected output. I'm going to put a breakpoint at the top of the switch on line 25. You always want to put the breakpoint around where you think the error is, on a line of code that will execute when you run the program. If I choose the top of the switch, I'll get to see the value in answer, and I'll get to see which cases are entered. So I will right-click in the margin next to the line numbers and choose Toggle Breakpoint, and then I will click the bug. I'm going to type a lowercase d at the prompt, And since we've now reached the breakpoint, Eclipse asks me if I want to change to the debug perspective, and I'll click Switch. Now looking in the variables area, I can see that answer is D, which is what I typed, so that's correct. You want to use the debugger to confirm your expectations and assumptions, and find the expectations or assumptions that are wrong so you can fix the code. I'm going to click Step Over, and we immediately jump down to line 40, the print statement in the D case. So far, so good. I'll click Step Over again, and notice we jump into the default case. That shouldn't happen. Do you see the error? It's the common one that I warned you about in the video on switch statements. We forgot the break. But is that the only error? If I'm in the default case, then the assert statement should throw an exception if I get in there with an answer of A, B, C, or D. But if I step over, this assert statement does not throw an exception, and so we move on to the print statement in the default case. I'm going to click the red square. We've found the error, the missing break statement in case D, and also another error, an incorrect assert statement. I see two things wrong with this assert statement. Let's talk first about the one that's probably the most common error. This assert statement says if the answer isn't A, or the answer isn't B, or the answer isn't C, or the answer isn't D. That logic will always evaluate to true. Remember that only one expression in an OR needs to be true for the entire OR to be true. If the answer is B, for example, then it isn't A. So the first expression is true, and so are the third and the fourth. It's also not C, and it's also not D. So the entire OR is true. No matter what you type, it's not going to be at least 3 of those letters, so the expression is always true. In a switch, if we get to the default, then each of the cases before the default was false, all at the same time. We need an AND. So it should read, answer isn't A, and answer isn't B, and answer isn't C, and answer isn't D. Let me change just that, and then run this again and enter D so you can see the assert throw an exception. Remember, by the way, to enable asserts, choose Run Configurations from the Run menu, then click x equals arguments, and then type -EA in VM arguments. You can see that's already enabled here, so if that assert expression had been false, it would have thrown an exception. Okay, so I've run it, I typed D, and it throws an assertion exception. Why? Because we have asserted that answer can't be A, and it can't be B, and it can't be C, and it can't be D, and it is D. But I do see one other error with the assertion, and that's that we are not including the uppercase letters. So it should also say, and answer does not equal uppercase A, etc. Okay, so to summarize, to test all of the paths through a switch statement, you will test the values for each case. Make a table of the inputs and the expected and actual outputs, and test each input, record the actual output, and find all of your errors. By the way, once you've corrected an error, you need to start over and test every single case again, in case you introduced a new bug. Don't worry, there are automated ways to run test cases, so you don't have to type the inputs in constantly. We're not there yet, though, so we're going to test by hand for now. Be sure to write an assertion in the default case. You want your assertion to say that the variable being examined does not equal each of the options joined by ands, and make sure you enable assertions while testing. Very good. That was fun. Now let's look at an example of a branching program that uses either an if or the ternary or conditional operator. This is a little more difficult because you're not necessarily testing for equality as with a switch statement. You could be testing any logical condition. And if statements can be more complicated. You can have serial ifs, nested ifs, or separate if statements. Let's look at an example. This program is called Average Altitude Buggy, and it's a combination of averagealtitude.java and averagealtitude-ternary.java with a bug or two thrown in for us to find. Think of it as a treasure hunt. Recall that in this program, we're asking the user for the altitude of 3 mountains, and we're calculating the average altitude. But if any of the values entered are less than or equal to 0, we're not going to calculate. We're going to print an error message. Now, this is a little different from our switch statement because the user could enter any number. We can't test all numbers for all 3 inputs. There are far, far too many. So we need to be strategic in how we test. We really only care if negative numbers, 0, and positive numbers are handled correctly. So we should test some negative numbers, some positive numbers, and 0. We want to test around the place where the test changes from true to false, called the edge cases. Think of that line between true and false as a knife's edge. We want to test -1, 0, and 1 because they're on the edge. But we should test a few other representative values as well. We might look up the highest mountain on Earth and make sure that number isn't too big for our program to process if we enter it 3 times. Remember, we're taking an average, so our program will need to represent 3 times the highest mountain on Earth. And then we need to consider that this program should print the average of the 3 values. But if any single value is less than or equal to 0, it should print an error message. So we should run it with the first value being less than 0 and the first value being 0, then the second value being less than 0 and the second value being equal to 0, and then the same for the third. We should test all 3 values greater than 0 and all 3 values at 0 and less than 0. We should test the first 2 values less than 0 and equal to 0, and then the second 2 values less than 0 and equal to 0, and then the first and third values less than 0 and equal to 0. Why? Because there are ways the program could have been written that would work correctly for some of those cases, but not for others. For example, if the programmer wrote a Boolean flag that gets set to true if a value is less than or equal to 0, but false if it's not, and they did the same for all 3 altitudes, then that third altitude is going to be the most important one, because the flag will always be set based on its value. But what if the programmer wrote the program so the values are tested in a different order? Any of them could be most important. When you're testing, it's important to think through not only the range of values, but also the different combinations of values that might impact the way the program executes. So for a program that isn't very long, there are a lot of cases we need to test to ensure it's working correctly. What I have here is a testing table that is almost all 1s and 0s. All 0s, all 1s, and then the 3 different ways we can have 1 0, and the 3 different ways we can have 2 0s, and then finally the altitude of Everest, the highest mountain on Earth measured from sea level, 3 times. What we're missing here is testing negatives, so I'd do the same tests with 0s but with negative numbers as well, and then some typical positive values to ensure the average is calculating correctly. Let me again speed up the video and run these tests and record the results. Once again, it's critically important that we write down the expected output before we test. Okay, and we get expected output for many of the test cases, including our largest mountains. A double can easily handle 3 times 30,000. But for 3 of the tests in which we should have gotten an error, we got an average. Again, we should head into the debugger to see what's wrong, running these sets of inputs. Let's try the first bad test case, 0, 1, 1. I'll put a breakpoint on line 20, the test after we've obtained the first input, and run the program in the debugger. And I'll enter 0 for that first input. Okay, we're on the test, and we can see has non-positive value is false, and altitude 1 is 0 over in the variables pane. I'll step over, and now has non-positive value is true. That's good. That means that one or more of the inputs is less than or equal to 0, and we shouldn't calculate an average. But we know that an average will be calculated, so let's figure out why. I'm going to continue to step and enter 1 at the next prompt. And we can see the value of altitude 2 is 1, and now I'll step over this assignment statement. And notice has non-positive value has been set back to false. This statement is just setting has non-positive value to the result of altitude 2 less than 0, and that's not right. It should be structured like the prior statement, setting it to true if the value is less than or equal to 0, but not doing anything if the value is positive, because we want to carry along the current value of the flag in case a prior value was less than or equal to 0. And we might notice, too, that this test is written as altitude less than 0, and not altitude to less than or equal to 0. So we could fix that at the same time. Now, if we do fix that statement on line 27, make both of those corrections, we need to test all of our test cases again. That's not the only error in this program, and when we fix it, there's always a chance we add a new error. So there is a lot to testing, and this is just an introduction so you understand how to design test cases for branching structures. You need to ensure each path through the program is tested, but you also need to test edge cases of your logical conditions to make sure you're choosing the correct path for the full range of possible values of the variables, and you need to consider permutations of inputs. The good news is that once you've designed a thorough set of test cases and run them on your code, or possibly somebody else's code, and it passes, you can have some confidence that your program is functioning correctly. And if it isn't, the test cases can help you pinpoint where it's going wrong so you can fix it. As usual, I have included a couple of auto-graded exercises in the description of this video so you can practice with the code. These exercises are tracers, allowing you to step through buggy code. This requires understanding what the code actually does, not what it's supposed to do. The buggy code is also available in my GitHub repository. When you're feeling confident with the concepts in this video, you're ready to move on to the next lesson. As always, have fun and keep coding.